All right, so we're diving into this paper on value-based deep reinforcement learning today.
Mm-hmm.
And I know you're super interested in like how this type of AI scales.
Right.
There's this kind of assumption out there that it's unpredictable, bit of a wild card.
Yeah.
But this paper is saying, hold on,
Yeah.
not so fast.
It might.
It claims that actually we can predict how value-based deep RL is going to scale if we give it more data, more computing power.
That's right.
Pretty cool, huh?
Yeah, so imagine you're trying to train an AI to play a really complex strategy game like Go. You would want to know how much better it would get if you gave it, say, 10 times the data.
Right.
Or a much faster computer to train on.
Yeah.
And this research says that contrary to what a lot of people think, we can actually make those predictions.
Okay, so before we get too far into the weeds here,
Yeah.
let's back up a little bit.
Sure.
For anyone who might be new to this whole AI world, what exactly is value-based deep reinforcement learning?
So think of it like teaching a dog a new trick.
Okay.
You give the dog a reward for good behavior,
Mm-hmm.
and over time, it learns which actions get it those tasty treats, right?
Right.
Value-based deep RL is similar.
Okay.
We're training an AI to make decisions in an environment
Uh-huh.
by rewarding it for actions that lead to the outcome that we want.
Okay.
So the AI learns to associate certain actions with a higher value, which just means that they're more likely to get that reward.
So it's all about teaching the AI to understand the value of its choices. Kind of like figuring out how to play a video game to get the high score.
Exactly.
Right.
And when we talk about scaling predictably in this paper,
Yeah.
it's saying we can know ahead of time how much data and computing power we need to reach a certain skill level. Like, imagine being able to budget for your AI project like you would for building a house.
Okay.
You know how much material you need for a certain size, right?
Right.
This research gives you that same planning power for your AI.
I like that. That's a
Yeah.
good analogy. Okay, now this paper brings up something called a Pareto frontier.
Mm-hmm.
I'm kind of curious about this.
Sure.
Can you explain what that is and how it helps us understand this whole scaling thing?
So imagine that you're trying to train an AI to predict stock prices.
Okay.
You could give it a ton of data,
Yeah.
but that requires really powerful computers.
Right.
And it takes a lot of time.
Uh-huh.
Or you could use less data.
Yeah.
But your predictions might not be as accurate.
Makes sense.
The Pareto frontier is like a visual representation of this trade-off.
Okay.
It shows you the different combinations of data and computing power that'll lead to similar levels of performance.
So instead of just like throwing resources at the problem and seeing what sticks,
Right.
we can actually use this Pareto frontier to be more strategic about it.
Exactly.
Find that sweet spot where we have enough data for good predictions, but not so much that it takes forever or costs a fortune.
You got it.
Okay, so why is predictability so important when we're talking about machine learning, especially as these AI models get more and more complex?
It's crucial because it directly impacts how efficiently we can develop and use AI.
Mm-hmm.
If you know how your AI will perform as you scale up the data and the computing power,
Right.
you can make much better decisions about how you're using your resources.
Yeah, that makes sense.
It's like knowing how much fuel your car needs for a certain distance so you can plan your trip and your budget accordingly.
And this predictability could be helpful in so many areas.
Oh, absolutely.
Like, imagine you're building a self-driving car.
Mm-hmm.
You'd really want to be sure that the AI is going to react in a predictable way in all kinds of situations, right?
Absolutely.
I mean, that's a safety issue.
In that context, for sure.
Yeah.
And even beyond self-driving cars, this applies to any field where AI is making important decisions.
So whether you're, I don't know, getting ready for a meeting about using AI at your company,
Yeah.
or you're just fascinated by this idea of making AI more efficient,
Mm-hmm.
understanding this whole predictability factor is key.
It really is.
It changes how we think about AI development.
It's about moving from a trial and error approach to a more systematic and informed way of building and deploying AI systems.
Now let's get down to the nuts and bolts of how value-based deep RL actually works.
Sure.
Can you walk us through the basics?
So at its core, value-based deep RL relies on something called a Q network.
Okay.
This network learns to estimate the value of different actions an AI agent can take within a specific environment. Think back to that dog learning a trick.
Right.
The Q network is like the part of the dog's brain that figures out which actions are more likely to earn a treat.
So if we apply this to a self-driving car example,
Yeah.
The Q network is helping the car understand
Right.
the value of different actions,
Exactly.
like turning left, turning right,
Uh-huh.
accelerating, braking.
It's constantly evaluating the potential consequences of those actions
Right.
and learning which ones are most likely to lead to a successful outcome.
Like reaching the destination safely and
That's
efficiently.
right.
Now, the paper mentions this updates to data ratio, or UTD.
Mm-hmm.
Can you explain what that is
Sure.
and why it's so important?
The UTD ratio basically measures how many times the AI model updates its understanding for each piece of data it processes.
Hmm.
Think of it like studying for a test, right?
Okay.
You might read the same material multiple times to make sure you really get it.
Yep. Yeah.
A higher UTD ratio means the AI is spending more time studying each piece of data,
Gotcha.
which can lead to faster learning.
So higher UTD ratio, faster learning.
Right.
But I'm guessing there's a trade-off somewhere?
Yeah.
Doesn't that mean you need a ton more computing power to process all those updates?
You're absolutely right. That's one of the key insights from this paper.
Yeah.
It reveals that by adjusting the UTD ratio,
Mm-hmm.
you can create a balance between the amount of data you need
Uh-huh.
and the amount of computing power required.
So it's like choosing between studying a little bit every day for a month
Yeah,
or cramming everything in the night before the test.
exactly.
Okay.
Both strategies can work, but they need different approaches and resources.
And this is where that Pareto frontier comes back into play.
Precisely.
It helps us visualize that trade-off between data and compute needs
Exactly.
and make smart decisions about how to allocate those resources.
Right.
Now, what's really interesting is that this paper finds this Pareto frontier to be predictable.
That's a key finding. Yeah.
So we can actually estimate how much data or computational power we need to reach a certain performance level.
Uh-huh.
It's like having a roadmap,
Right.
telling us the most efficient way to get to our destination.
That's a great way to put it.
So instead of just throwing resources at an AI project blindly,
Yeah.
we can actually approach it strategically,
Yeah,
optimize our efforts.
absolutely.
Really cool stuff.
Yeah.
We're seeing how this research could really change the game for anyone working with AI.
Yeah.
It's like giving them the tools to make better decisions about how they go and train their AI models.
Exactly. It takes away a lot of the guesswork.
Okay, so we've got this UTD ratio
Uh-huh.
and the Pareto frontier,
Right.
and we're seeing how they work together to show us the relationship between data, compute power, and performance.
Yeah.
But I'm wondering how this actually plays out in real-world situations.
Hmm.
Can you give me an example of how someone might use these insights in a practical way?
Sure. Let's say you're developing an AI system to help doctors diagnose diseases more accurately.
Okay.
You've got access to tons of medical data, patient records, lab results, imaging scans, you name it.
Right, mountains of data.
But processing all that data takes serious computing power.
Yeah.
And you might be working with a limited budget.
So you've got to find a way to balance the amount of data you use with the computing resources you have.
Exactly.
Okay.
And that's where the UTD ratio and the Pareto frontier come in.
Uh-huh.
You can use them to figure out the minimum amount of data you actually need
Right.
to train a model that's both accurate and efficient.
So you're not just throwing all the data at the AI and crossing your fingers.
Right.
You're being strategic,
Exactly.
tailoring your approach to the specific needs of the project.
Exactly. It's about finding that sweet spot
I see.
between having enough information to make a good diagnosis
Yeah.
without overwhelming the system with unnecessary data.
It's like finding the right balance.
Exactly.
Okay, so this approach could be used in a lot of different applications.
Oh, absolutely.
Like, what if you're trying to optimize the energy consumption of a huge building?
Mm-hmm.
You could use AI to analyze data from sensors all over the place
Right.
and predict energy usage patterns.
Mm-hmm.
But you wouldn't want to waste resources by collecting and processing more data than you actually need to make those predictions.
You got it.
It seems like this predictability factor could be a real game changer for budgeting and planning these AI projects.
For sure.
You could get a much better estimate of how much computing power you're going to need,
Right.
avoid blowing your budget.
Exactly. It takes away a lot of the uncertainty.
And that leads to something else.
What's that?
Predictability isn't just about efficiency.
Okay.
It's also about trust.
Oh, I see what you're getting at.
I mean, how does knowing how something's going to scale make it more trustworthy?
Think about it this way.
Okay.
If you understand how an AI system is going to behave as you scale it up,
Right.
you can have more confidence in the decisions it makes.
Hmm.
You're not just relying on a black box.
Yeah.
You actually understand the principles that are driving its behavior.
Right.
And that understanding can lead to greater trust,
Makes sense.
especially in those critical situations where the AI is making big decisions.
Like in healthcare, right?
Exactly.
Doctors and patients need to trust that the AI is giving accurate and reliable recommendations.
For sure.
And that trust comes from knowing that the AI is predictable and transparent.
Absolutely. And this applies to any field where AI is being used to help people make decisions.
So it's not just about making AI more efficient, it's about making it more trustworthy,
Exactly.
something that benefits everyone.
It's about making sure AI serves us, not the other way around.
Now, I noticed the paper mentions specific algorithms
Mm-hmm.
like SA, BROA, and PQL.
Yeah,
I have to admit, I'm not familiar with those terms.
sure.
Could you give us a quick rundown of what they are?
Yeah, those are different algorithms for actually implementing value-based deep RL.
Okay,
You can think of them like different tools in a toolbox.
gotcha.
Each one has its strengths and weaknesses.
So you might pick one over another depending on the task you're trying to accomplish.
Exactly.
But even though the specific algorithm might change you from project to project,
Yeah.
the underlying principles of predictability and scalability that we've been talking about,
Mm-hmm.
those still hold true.
Absolutely.
It's like having a set of universal guidelines
Right.
that you can apply across different types of AI projects.
It's a framework for approaching AI development in a more strategic and systematic way.
Before we move on, I wanted to touch on something we haven't really talked about yet, data quality.
Okay.
I mean, we've talked about how much data you need,
Yeah.
but what about the quality of that data?
Good point.
Does that play a role in this whole predictability thing?
Absolutely. You can't just focus on quantity.
Yeah.
Having a ton of data doesn't mean much if it's full of errors or inconsistencies.
It's like baking a cake. You
Uh,
can have all the ingredients in the world, but if they're not fresh
Right.
or measured correctly,
yeah,
the cake's not going to turn out right.
exactly. Garbage in, garbage out.
Right.
The quality of your data is crucial for predictable scaling.
Okay.
If your data is noisy or biased, your AI model is going to learn the wrong things.
Yeah.
And its performance is going to be all over the place.
So it's not just about collecting as much data as possible.
Right.
It's about collecting the right data,
Exactly.
data that's accurate,
Mm-hmm.
relevant,
Yeah.
and representative of the problem you're trying to solve.
That's why data preprocessing and cleaning are so important. You need to make sure you're feeding your AI model good stuff.
High quality ingredients
Exactly.
if you want predictable and reliable results.
Absolutely.
So data quality is key.
Mm-hmm.
What about the design of the AI model itself? Does the architecture of the model affect how predictably it scales?
Absolutely. Just like you need a solid foundation for a skyscraper,
Okay.
you need a well-designed architecture for your AI model if you want it to scale effectively.
So if the architecture is too complex,
Yeah.
it might be really hard to train
Right.
and need way too much data and computing power.
And on the other hand, if it's too simple,
Yeah.
it might not be able to handle the complexity of the problem you're trying to solve.
So it's all about finding that sweet spot again
Exactly.
between complexity and efficiency.
Right. And there's no one-size-fits-all solution.
Right.
The best architecture depends on the task and the data you're working with.
And this is where human expertise is still essential, right?
Oh,
I
absolutely.
mean, we can have all these guidelines and principles,
Yeah.
but we still need people to design these models
Uh-huh.
and make the decisions about the best approach for each project.
AI is a powerful tool, but it's not magic.
Right.
We still need human ingenuity and creativity to design, develop, and use these systems effectively and ethically.
So it's not just about the algorithms and the data.
Right.
It's about the people behind them.
It's a collaboration between humans and machines.
Yeah.
The success of AI depends on how well we work together.
I think that's a great place to pause for now.
Okay.
We've covered a lot of ground,
We have.
from the basics of value-based deep RL
Uh-huh.
to the importance of data quality and model architecture.
It's been a great conversation.
It has.
I hope it's given our listeners a better understanding of how to approach AI development in a more predictable and efficient way.
All right, so we've really gone deep on value-based deep reinforcement learning
We have.
and how this research is saying, hey, maybe it's not as unpredictable as we thought.
Right. There are ways to understand how it scales.
We've looked at some of the big ideas that help us control these systems as they grow.
Mm-hmm.
But I want to zoom out a bit now.
Okay.
What do you think are the long-term implications of being able to predict how AI scales?
That's a big one.
What doors does this open for us?
Well, I think it has the potential to totally change the way we develop and use AI systems.
Like how?
Imagine a future where we can just confidently estimate the resources we need to train an AI to reach a certain level of performance.
Okay.
And not just in one field.
Right.
Healthcare, finance, even something like climate modeling.
So we're not just throwing money and computing power at a problem and hoping it works out.
Exactly.
We can plan our AI projects with way more accuracy and efficiency.
It's like having a roadmap for AI development.
I like that, a roadmap.
Yeah.
And this predictability doesn't just affect efficiency, right?
No, not at all.
It also impacts trust and accountability.
Now, how do you see those two things connecting?
Well, if I understand how an AI is going to behave as it scales up,
Yeah.
I can be more confident in the decisions it makes, right?
Okay, I see what you're saying.
It's not this mysterious black box anymore.
Right.
I actually get the principles behind how it works.
Uh-huh.
And when I understand it better, I trust it more.
That makes sense, especially when AI is making decisions that affect people's lives in big ways.
Exactly. Like using AI for medical diagnoses.
Yeah.
Doctors and patients need to be able to trust that AI, right?
Absolutely.
And that trust comes from knowing it's predictable, it's transparent.
You need that foundation of understand.
So it's not just about efficiency.
It's about so much more.
It's about making AI more trustworthy, more reliable.
And that benefits everyone.
Exactly. AI should be working for us, not the other way around.
Couldn't have got it better myself.
Okay, one last thought before we wrap up.
Okay, shoot.
We've been talking about value-based deep reinforcement learning specifically.
Right.
But do you think these same predictability principles
Mm-hmm.
could apply to other types of machine learning?
That's a really interesting question.
It is, isn't it?
And I think a lot of researchers are trying to figure that out right now.
So there's this whole push for more transparent, interpretable AI models,
Yeah,
and understanding predictability is a big part of that.
definitely.
So maybe we're moving into a new era of AI,
A new era.
where these systems are not only powerful but predictable and understandable.
That would be amazing, wouldn't it?
It would.
We could use AI in even more creative and impactful ways.
Well, I think that's a fantastic note to end on.
I agree.
Thanks so much for sharing your insights with us today.
My pleasure.
I know I learned a ton,
Me too.
and I'm sure our listeners did as well.
I hope so.
To everyone listening, thanks for joining us on this deep dive.
It's been fun.
We hope you enjoyed it, and we encourage you to keep exploring this incredible world of AI.
There's so much to discover.
Until next time, keep learning, keep asking questions, and keep pushing the boundaries of what's possible.
Absolutely. Never stop exploring.
When one